Hi, my name is Bianca Lopez Parnetti, and this is my presentation on Lab 4 oscillations. Alright, so the purpose of this lab was to track the movement of a spring oscillating and then compare it to a computational model on GlowScript. So the main physics principle used in this lab was conservation of energy. So the main forms of energy in this one were gravitational, spring, and kinetic, and they were all in the system, and I'll explain that a bit later. And so the relevant equations were just all for these different kinds of energies to calculate each component and then how they all add up for the total energy. So as a preview for the main lab results, we can see that something went wrong because the experiment and the model are supposed to line up with on the graphs, but they don't. On the X position one, they both at least have movement, but on the Y position graph, the model component of the graph is just a flat line. So, the system and surroundings for this lab, the system was the spring, and that included all the forces and then therefore all the energies acting on it. So that includes gravitational, spring, kinetic, everything was in the system, so there was really nothing in the surroundings. And then here are the initial conditions for everything in the lab. For example, we have the mass, which was 0.402 kilograms. You have the initial time of 0, the time step, the initial position, and then the spring constant, which we calculated to be 6.83 newtons over meters. Alright, so the first part of this lab was to set up the tracker. We got the video from the lab material itself, and then we had to input it onto tracker, calibrate it, and then track it as a point mass to see how it oscillated throughout. And then we created the computational code, which modeled the experimental code version of it. So on the left you have all the initial conditions, which I explained earlier, and then on the top right is basically all the energy components of it, and then how we change the velocity and position, for example. So all the updating motions as well. And then on the bottom left, we have more energy. It was all a repeat, but it's just explaining how all the energies really were set up and then how they were calculated to visualize the movement of the spring. Alright, so these were the results of the lab as previewed before. So one component, the experiment or the red line, is correct, that motion of it going down and up and down and up to show the oscillation in both the X and Y direction. That's correct. The model part of it was wrong because it was either a lot more dampened, so the amplitude was a lot smaller, which means it didn't go as high up or as high down in both X or Y. So X was really calm compared to the red one, and then for Y it was just a flat line. So similarities between the experiment and the model. Obviously, the only really similarity was that there was oscillation in the x-axis one, where the spring was showing the movement back and forth, but the main clear difference was that it didn't model the movement of the spring correctly, and the model movement was really heavily dampened or just non-existent, meaning it was just the straight line, and it didn't show it moving up and down, up and down. So possible sources of error. I was sick this week, so I had to go through tracker alone, and I'm on a MacBook, so it really sucked. Also, this was just a weird lab. Everyone was kind of having issues with it, and I just didn't have the time to email the head TA about it. But at least I still understood the lab. So for the additional questions, we just had a single what does it mean? And the first part of the question was asking if the energy principle was satisfied. And I said it was not, because all of the energies, all the different components, kinetic, gravitational, and spring, were supposed to add up to a total energy of 0, but they clearly didn't as per the first graph. They were all just kind of going their own ways, or just not show up at all. And then for the second part, it was asking about two estimates about the oscillation periods, first for the X position and then second for the Y position. And as you can see on this bottom graph, they have the same oscillation periods, and you can tell that by just where two separate points like continuously add up for the same Y value. So as you can see with these little blue lines, they're basically the same period, but they kind of shifted for each one, but on average they were the same. So that was it. Thank you so much for listening.